Welcome, everybody, again to our August Fireside Chat. Tonight's theme is on climate adaptive tree species. What can we be planting out there, or what can we be managing for as the climate changes? What are climate resilient tree species? So we're going to dive into that a little bit. A little bit of context first for these Fireside Chats. We have been doing them since January. Hosting one every month on a different topic related to ecological forestry. We took last month off. I think I was on vacation, or somebody was on vacation. Maybe we all were. But we'll continue to get back into a regular swing of Fireside Chats between now and the end of the year. And next month is going to be a double hitter, or a two hitter, double header. There we go. I'm not a baseball fan. Double header. And they're both are going to be somewhat specific to San Juan County, but relevant, I think, to everybody. And I know at least one of the topics is going to be on biochar and managing forests for fire resilience. And we'll be joined at the next two Fireside Chats also by Kai Hoffman-Krull, who's with us this evening. Kai is the Forest Health Director for the San Juan Conservation District, and I'm pleased to have him join us tonight. I've worked with Kai for years in across the San Juan Islands, helping small woodland owners manage their forests, adapt their forests to climate change. And I thought it's very relevant for this topic this evening to have Kai join us, given the forest ecology that he hails from. A very dry part, unusually dry part of Western Washington, being in the rain shadow that the San Juans are. Guy is on the front line of climate change and has been working again with constituents in his area to help them understand climate impacts on their forests and how they can make their forests more resilient. So tonight's going to be a great conversation, hopefully between Kai and I. Sharing some insights into climate change and its impacts on forests, and again, what you can do from a management standpoint to help your forests be more resilient. As always, I'm also joined by Alex Dolk, our program director, and this whole Fireside Chat series was Alex's genius idea. So we're just trying to make good on her good idea. And she's running the scene here, kind of behind the scenes. She will be managing the chat function on Zoom. And so as we go through the first half hour or so of our conversation, if you have any questions or have any ideas that you want to propose, go ahead and type them into the chat box, and Alex will monitor that. Once Kai and I are done chatting for the next 20 minutes, 30 minutes or so, Alex will take a look at the questions that you've put in there, and Kai or I will attempt to answer those. And then we'll open up the meeting here to just a group discussion. And I would love to hear from any of you what your insights are into making your forests more resilient to climate change. So, Alex, is there anything that I overlooked as far as introductions go?
Nope, I think we're good. Thanks.
Okay. And Kai, I'll let you provide a more detailed introduction to yourself when I pass the talking stick over to you. So, all right. Well, to create a little bit of context and just to give you something that hopefully makes you go, I want to share a bit of a perspective, a little bit of philosophy of mine on Northwest forests in the face of climate change. As a consulting forester, I travel all over Western Washington, meeting with different forest owner types. And a lot of folks, of course, increasingly are contacting me with a great concern over the mortality that they're seeing in their forests. They're seeing cedar dying off, hemlock dying off, grandfir dying off, just overall increasing rates of mortality. And one of the most common concerns that they express to me is this climate change? Is this the effect of climate change that we're seeing in our forests? Because we're seeing such a dramatic increase in tree mortality. And I've spent quite a bit of time thinking about that. And of course, looking at these forests, looking at mortality within these forests, And I've come up with a little bit of a different perspective that doesn't lead me to immediately finger climate change as the primary causal factor. So consider this. Arguably 95% of the forest cover in Western Washington, perhaps across the state, is in a disturbed condition. In other words, it's not pristine old growth. It's been logged in the past, it's been altered in some fashion, and is in fact in some state of recovery, if you will. A lot of these new generation forests, if we can call them that, are very, very highly stocked compared to the historic condition, the old growth condition. And if you start thinking about natural forest development and forest successional processes, the stages that a young forest or a growing forest goes through on its eventual path towards old growth conditions, forests pass through all sorts of different phases of natural disturbance. Natural disturbance being sort of the primary agents that shape forest composition. And natural disturbance can be wind events, can be disease, can be pests, can be fire, can be ice storms, etc. And what each of these different disturbance events, in effect do is thin the forest or adjust the forest composition in one way or another that leads eventually towards increasing structural heterogeneity and ultimately, unless some other major disturbance event occurs, to an old growth condition. So this has led me to realize that a lot of the mortality that we're seeing in forests right now is not necessarily solely due to climate change, but our forests going through a natural thinning process. So again, back to my earlier point that a lot of our forests are overstocked. There's a lot of competition between the trees for resources, sunlight, soil moisture being the two primary limiting factors. And as that competition increases and stress is put on these trees, mortality is a natural process of that forest beginning to thin itself and reduce its stocking density. The other aspect of this is most of the hardwood and conifer species that we have are very efficient at producing seed and producing a lot of seed and casting that seed out over all different soil types. Now, not all of the species that are naturally regenerating are necessarily suitable for the soils that they're growing on. Take cedar or hemlock, for instance, that are relatively drought intolerant tree species. They can just as well germinate on a glacial soil or on sandy soils and probably grow just fine for a number of years. But that doesn't mean that that tree is suitable for that site in the long run. And whether or not climate change, or even if climate change was not happening, I should say, those species likely would die off on that site just because they're not suitable for it. So I want you to keep that in mind, that as you go and look at your forests, think about what is natural forest development, what is natural stand thinning, or how can that factor into your forest? And is that in fact what's happening? Now, certainly climate change is going to exacerbate this as things get drier, or in the wintertime as things get wetter. And those kind of disturbance agents, bear an increasing effect on our forests. But I just want to leave you with that to kind of ponder as we dive into a deeper discussion about climate adaptation. So I'm going to leave it at that. We're going to circle back to managing forests for the right species in the right location, managing for stocking densities. But I want to pivot for a moment and pass the talking stick over to Kai Hoffman-Krull, again, the Forest Health Director for the San Juan Conservation District. And Kai's got a really interesting perspective on historic climate and species in the Northwest that he's going to share with you. And then we'll get into a bit of a back and forth and run through hopefully a bunch of different little topics relating to climate adaptation. So Kai, thanks for joining us.
Yeah, great. Thanks so much, Kirk. And it's a pleasure to be with all of you and to be talking about such a relevant subject. So many of us are in this spot of asking questions around what climate change means for us and definitely means for our forests. And so there's a series of different perspectives that we can take with that question. This notion of climate migration is one that many of us are starting to become familiar with, in terms of that this tree species and the overall forest composition that we have today may not be what we are moving towards. So how do we plant and look for species that are going to be supported and more resilient in the changes to come? And Kirk definitely cited sort of, part of what defines climate change is that we're moving into a period of unpredictability, right? That we're going to be having changes in weather patterns that we really can't foresee. But that being said, many of the models do predict that we're going to have somewhat similar amounts of moisture content, but more concentrations of that moisture content in the wintertime and larger amounts of drought periods during the summertime. And so that means challenges for tree species on a couple of different fronts. One being, that of course we know that the droughts are challenging for trees, and that all trees go through some period of stress through long summers, but usually that minimal stress is of course addressed when the fall rains come. Now you go through a series of years where those stress periods are extended because of drought, and then you start to really weaken the overall vitality of those trees, and there does become more susceptibility to these other disturbance agents, disease and pests certainly being two of the ones that Kirk just mentioned. But then also the concentrated rainfall in the wintertime can also have challenging effects as well. You have high water tables and oftentimes then anaerobic environments in certain locations, which means that oxygen isn't able to access in the same proportions into those soils, and that then results in essence decreased overall biological activity, and oftentimes then the resulting development of pathogens, specifically laminate root rot, is oftentimes found and grows in high amounts once the water recedes from that anaerobic condition. So these are two of the kind of key challenges, both high water table saturation periods in the wintertime, drought periods in the summertime, that we're going to be looking to see. Again, very generalized. So, and then as we sort of think about, okay, so how do we start to look for climate resilient strategies? And certainly the stocking issue is paramount, and I think we'll be talking about that quite a bit tonight. So Kirk, thank you so much for bringing that up. I want to bring in sort of another perspective, which is, as we look at this climate migration piece, a couple different theories on sort of how we look at what tree species may be best suited for Western Washington in this changing climate. One of those theories is, of course, going further south, right, where temperatures are historically warmer, and so looking at Oregon, California, what are some of the tree species, and even some of the species that we have here, collecting seed from those locations and seeing if those may have some increasing viability. Then you have the other strategy of going east, right? Going to the mountains, going even potentially across the mountains and seeing some of the species that are thriving there in more obviously droughty conditions, and looking at some of those as species that could be increasingly resilient in Western Washington. And then the third one that we're going to talk a little bit about right here is the deep time look at species. And the climate has not been historically always what we're at now. And so looking at some of those climatic patterns, can that give us insights into some of the species that may thrive because they used to thrive in Western Washington and may thrive more again with some of the conditions that we're moving towards? And so this is just a very brief summary of a very extensive research project that was done by Henry Hanson. I'm guessing not related to Kirk, but from an OSU professor. And this was looking at bog and marsh sediment cores all through Western Washington, basically all the way up through Mount Vernon and all the way down towards Tacoma. And again, this is very high level summary, so forgive the lack of full on details. But this period that I really want to concentrate on is sort of the glaciation period, right? So right around 14 to 12,000 years before present, we have this, especially higher up, towards San Juan County, but the glaciers are affecting, even the glaciers higher up north, are still affecting all the way through Western Washington. These miles of tall ice are influencing temperatures all the way through the region, and so many of the parts of Western Washington were known as a tundra landscape, an alpine tundra landscape. Much of how we might think about if we were to go climbing up in the mountains and the Cascades, we'd be looking at somewhat similar types of conditions in those areas. And so some of the species that were really thriving during that glaciation period were lodgepole pine, mountain hemlock, Sitka spruce, alder, red alder, and Ponderosa pine. So, we tend to think about Ponderosa pine as this east side species, but really a species that used to thrive here in Western Washington. And then you move into about 10,000 years from present, and we have the development of the main tree species that we know, Douglas fir. And within 1,000 years, Douglas fir goes from being a newly introduced species to the dominant species through that whole time period. So it's obviously very effective at growing significantly. But then there's this period that I want to really focus on, which was basically 9,000 years before present to 4,500 years before present. And that's when we actually moved into a warmer period, where projections are somewhere that climatically we were at 3 to 4 to potentially even 5 degrees warmer than we're at now. So again, a much drier and warmer climatic period. And the dominant species during that period were Douglas fir, Gary oaks, and hazelnuts. And so that's a really interesting piece to be considering, is that this sort of savanna structure, when we talk about sort of different forest compositions, we talk about forests, and then we talk about woodlands as sort of this in-between, more thinned out. Tree counts were somewhere between 60 to 120, some of the projections I've heard for woodland structures today. And then you look at savannas, where you're at something closer to 20 to 30 trees per acre, very spaced out grassland savanna. And that's really where, again, Gary oaks and hazelnuts thrived. And so, again, we'll dive into some more details later, but I want to leave you with that concept that these sort of open savanna structures that we've in many ways lost because of moving into this cooler, wetter period for the last 4,500 years, where conifers really became the more dominant species because they were more fostered in that cooler conditions. Many of those conifers may become more challenged. Not Doug fir, because we see the Doug fir was still really successful in that warmer climate period. But many of the other conifers that we've come to know these forests by may become increasingly challenged, and we may be looking at some of those deciduous species that, again, really thrived in this location. So again, overall high summary of this sort of deep time analysis of some of the species in our area. And then with that, would love to hand it back over to Kirk, and let's take it from here.
Awesome. All right, boy, you gave us a lot to unpackage there. So that's great. Let's see if we can kind of peel that apart and take it topic by topic. I think what I want to start with is, for most of you that own forests or managing forests, you have a certain complex of species that you're already dealing with. Your forest, let's assume, is well stocked, fully stocked with a range of hardwood and conifer species. So obviously you need to work with what you have. Before we get to the point of introducing, new species or new genetics, I think one of the best considerations is, what do I do with what I already have to help it be more resilient to a changing climate. And I think that comes down to two basic strategies, and one we already mentioned, and that's thinning. That if we can accept the argument that most of our forests are overstocked relative to the long-term carrying capacity of that site, then it stands to reason that thinning is our best strategy to reduce competition between trees. One of the comparisons that I like to make to really make this point is that, again, if old growth is your desired future condition, and when I say old growth, I'm defining it as, the really large dominant trees that we see in intact old growth forests out there. Wherever I go hiking in old growth, almost without difference, the stocking density of those very large big trees, is somewhere between 25 and maybe at most 100 trees per acre. So if we can assume that is the carrying capacity, the general carrying capacity of a site for large old trees, and if we are starting with a forest that is 200, it has 200 trees per acre, 300, or maybe it was just planted and still at original plantation density of 400 trees per acre, then again, it should stand to reason that site is overstocked for the long-term carrying capacity of the site. And we need to think about thinning. So thinning is going to give us two opportunities. It's going to allow us to reduce the competition between the existing trees and make some tree selection or species selection decisions. So back to an earlier point that both Kai and I made, is that the current species on the site may not be suitable for that site in the long term. So it really behooves you to understand your soils. In particular, if you have droughty soils, glacial till, sand, or a south-facing aspect, or if you're at the top of a slope, top of a hill, or higher up on the hill slope, in other words, a well-draining site, there are certain species that may just not do that well there, and those are hemlock, potentially cedar, west side grand fir, red alder. Those are probably the four, the Sitka spruce. Probably the 4 or 5 most common species that are the least drought tolerant. And if you have those on those sites and they are competing with more drought tolerant trees, then during your thinning, you may want to proactively cut those out to favor the more drought tolerant trees, the Douglas fir, the white pine, the ponderosa pine, the lodgepole pine, the big leaf maple. If you have it, the oak, the madrone. These are all species that are very, very drought tolerant. So that's one initial take there, is understand your soils and understand the effect of stocking on your overall forest composition. Kai, do you want to add anything to that?
I think that's a great summary. And I think that understanding your soils is one of the best keys that you can have to be understanding these resiliency factors. I think that one of a great tool, a very simple tool that you can use, is actually just going out with a piece of rebar, like a 3-foot piece of rebar and a hammer, and go and just hit that piece of rebar down into your soils and find when it starts to hit something a lot harder, when you start to hit hardpan or bedrock, and that'll give you a sense of your soil depth. Now, that is just one sort of foundation point of understanding the access your trees have to different soil nutrients and water, but the pliability, which is basically in essence how easily soil roots can move through the soil structure. That little test of pounding that rebar is just a really simple, great tool to understand how far are these roots easily being able to travel to access that nutrients and water. Some other pieces to consider is how deep is your horizon layer. That's the topsoil, high organics layer. Some locations of Western Washington, that can go over 1 foot deep. And some areas, especially in San Juan's, we have really thin glaciated soils where those glaciers just dumped all different types of soils all over the place. So some areas that can be 6 to 8 to sometimes 12 inches deep. Sometimes that's 2 to 3 inches deep. So going through and really trying to see how, your compost pile at home, that rich humusy soil, go into your forests and see, your top layer probably is going to have that high organics, high humus, sort of black stick to your hand humus. How far deep does that go? And that'll again give you sort of indications on the resiliency factor, because a lot of that humus is both increasing biological activity, holding on to nutrients, and certainly holding on to water. So those are just two kind of basic ways to be understanding how well your soils are increasing the resiliency of your trees.
Yeah, great. So let's also think about, now I listed off a range of tree species that are not drought tolerant. So I don't want people to just automatically go out there and now start cutting these species out of their forest willy-nilly. Let's also think about where those species are going to do well. So understanding the topography of your property is going to be very important. If you have a lot of topographical variation in your property, if you have north-facing slopes, if you have land that occurs lower in the landscape profile, say at the base of a hill or in valley bottoms, if you have drainages or draws on your property that are cooler, shadier, moister, those are going to be great refugia for the less drought tolerant species. Again, the hemlock, the cedar, the alder, spruce, etc. And those are areas that if those species are there, conversely, you may want to think about cutting out some of the more drought tolerant species on those sites to favor the less drought tolerant species. And that way, again, across your whole property, you're able to maintain species diversity. And again, I consider that whole strategy to be right tree in the right location. So one of the concepts that Kai brought up also is this notion of assisted migration. And assisted migration can refer to both bringing other tree species that don't currently grow in our region up from southern latitudes and planting them, but it's more commonly refers to bringing up genetic stock of the same species. So in other words, Douglas fir, white pine, cedar, from Southern Oregon, Northern California, et cetera, and planting that up in our area here. There's a great tool that you can, a great online tool that you can take a look at. It's called the Seedlot Selection Tool. If you Google that, Seedlot Selection Tool, it's an online software program developed by the U.S. Forest Service and allows you to put in your current location and then run a little model and see where and what southern latitude currently is representative of the climate of the Northwest, say 60, 80 years in the future. That will allow you then to go and look at an area, look for nurseries or look for tree stock, seedling stock from an area that presumably is representative of our future climate. What we've done a number of assisted migration projects where we've planted out seed stock from southern latitudes. And the general kind of rule of thumb is rather than putting all of your seedlings into one basket, if you will, is to only plant a certain percent of your planting stock with these off-site genetics. So maybe 20% or at most 25%. So you're getting those genetics spread out there. But not in completely relying on that. So we do know from experience that planting offsite genetics can also have some unknown and potentially undesirable consequences in tree growth. So you want to be very careful. And of course, monitoring is critical. So taking those trees, putting a stake next to those trees, some flagging on those seedlings, and then watching how they develop over the years. Are they truly adapting to our climate? And I hadn't really considered this, but Kai, I'm glad you mentioned of thinking of the east side of the Cascades for seed stock. Of course, that makes a tremendous amount of sense, and certainly is more local to look towards nurseries over there. And again, bringing a small percent of those, mixing those into your current planting. Anything else you want to add to that, Kai, or build off of that?
Yeah, I mean, I think that just one of the species that really stood out to me in terms of this assisted migration concept, because it's both fits into the east side conversation as well as the deep time analysis, was this Ponderosa pine piece. I grew up in Spokane, Washington, so grew up in Ponderosa pine country, and thinking about it as a tree species that up till about 9,000 years ago lived within Western Washington is an interesting concept to think about potentially looking at, we're all kind of in experimental stages, right? With this whole concept. Again, part of what defines climate change is how much we just don't know of what some of these patterns will look like. So we're all trying some different strategies, and I think, as Kirk mentioned, monitoring is really critical. So you're all researchers in this equation, but I think getting some seed stock from the east side, or again from the Cascades, would be a really great opportunity to plant some Ponderosa pine and see how it does.
So we've listed a number of strategies here. Now we've talked about thinning. We've talked about assisted migration, both in genetics and in other species. We've talked about moving existing tree species around, so you've got the right species on the right location. One thing that we haven't talked about yet, or I guess we've just alluded to, is what other kinds of species can we bring up? And this is somewhat controversial, or I guess I'm surprised that it's kind of controversial, but is I think more and more people are thinking about planting sequoia and redwoods here. I know a lot of folks are doing that. I've put a few out of my land just to see how they grow. Arguably, they're native. I think looking back at the pollen record, at least, I'm not sure both of those, at least redwood grew here. And I forget exactly how long ago, long time ago, pre-glaciation anyway. So if you want to suspend your temporal expectations, we can say that redwood is a native species. But both obviously very drought tolerant and comfortable with warmer climates. And there may be other species like that as well. So depending on your native plant purist sensitivities, I'll let you mull that one over. Let's see. There's one other thought I wanted to add. Yeah,
I just have a few species that I'd love to throw in there as well. We're on it. So yes, one of the most climate resilient tree species that we can look at is Gary oak. So again, as I mentioned, it was one of the dominant species from that 9,000 years to 4,500 years before present. But it also was one of the dominant species all the way up till about 200 years ago. And that even though the climate wasn't perfectly set for the growing conditions, it was cultivated through fire. It was an incredibly fire adapted. That's a whole. We could do a whole presentation just on the climate adaptability, climate adaptability and the fire resiliency of Gary oaks. They have this incredible epicormic structure that is actually kickstarted by fire. But in essence, it was the Coast Salish people all throughout the Puget Sound region were cultivating Gary oaks and the whole ecosystem beneath them as one of the main farmland areas. A colleague that I work with at the Tulalip Natural Resource Department said, where you see Gary oak savannas, that was our farmland. And so, and they are known for being some of the most drought tolerant species. They also can handle high saturation periods in the winter. They do great in high heat and cold conditions. Their biggest weak link, as Kirk would indicate, with this concept of overstocked stands, is light access. They require significant light access, and most of the conifers, especially Doug firs, will just grow faster than Gary oaks. So if you have areas that have access to significant sunlight, consider planting Gary oaks as a very climate adapted species for where we're heading. A few others to add in there. Western white pine was one of the most dominant conifer species about 200 years ago within Westside forests. There was a blight that killed off more than 90% of Western white pine. Finding blight there's been a number of different nurseries. Actually, University of Idaho has been really leading some of that work on breeding blight-resistant Western white pine. But again, in terms of drought-tolerant conifers, they're at the top of the list, and they also will handle most soil conditions. Similar to Gary oaks, their biggest Achilles heel is access to sunlight. So if you have an area with an open open area and an area that you're planning on doing some maintenance in terms of doing some thinning, then Western White Pine could be a great fit. Rocky Mountain Juniper, as well as Maritime Juniper, if you're on the coast, two species that again can handle a lot of significant drought conditions, most soil conditions. And within San Juan County, you'll see them growing out of straight rock. So if they can grow out of straight rock, they can probably handle most good soil. Again, common theme here you'll be hearing, their big weak link is competition for sunlight. So again, if you're doing thinning, you have an area that is opening up, consider either Rocky Mountain or Maritime Juniper. And then again, the beaked hazelnut, as I mentioned before, one of these species that was dominant within our region about 4,500 years ago. Certainly still you'll see it throughout the region, but another good one that not only is beneficial for drought resistance, but also a great wildlife habitat food. So if you want to feed the critters, plant some beaked hazelnuts.
I'll add just a few more to that. I'm looking at, and this is been meaning to make this point, on NNRG's website, my organization's website, we have a whole section on climate adaptation. And a number of years ago, put together a guidebook for forest owners and managers all about adapting your forest to climate. So I think, Alex, if you can put the link to that page in the chat box, folks can go there and look for this guide. And in the guide, there is a list of species that are considered to be climate resilient. And so Kai has mentioned quite a few of those. I mentioned some earlier. A few that have not been mentioned yet is our native mountain ash, our native Douglas hawthorn, black hawthorn, Pacific dogwood. And then just to go through some of the other common ones, again, Douglas fir, Oregon oak, big leaf maple, Ponderosa pine, Pacific madrone, lodgepole pine, and western white pine. So those are going to be kind of hopefully your star players in the face of climate change. So I think with that, what I'd love to do now is open it up to some questions. I think a few of them have come into the chat box, and Kai and I can field these, and then we'll open it up to a discussion and see what other thoughts that folks have. Alex, what are you finding in the chat box?
Yeah, so I'll read out the questions, but if the people who ask them want to elaborate, feel free to go, just unmute yourselves. But Mark asked, when considering thinning, how should we come up with the carrying capacity per acre?
Good question. So first of all, one thing that you don't want to do is go from your current stocking, assuming that it's a high stocking. Let's say anything over 200 trees per acre, I consider to be a high stocking. You don't want to go from that straight to this presumed ideal carrying capacity. Let's say it's 25 trees per acre, 50 trees per acre. You're going to want to gradually thin your stand down to that. So then the question is, okay, well, if I'm going to come in and thin, what density should I be thinning to? What I encourage you to do is look up a stand density index or stand density guides. Just Google either of those terms. And you can even have the species: red alder stand density index, Douglas fir stand density index. And you will find some documents that show you they'll show you growth curves that use tree age and or tree diameter rather, and tree height as two variables to determine what the ideal stocking density. I'm sorry, tree age and tree diameter to determine what the ideal stocking density is for your forest. The USDA has a great stand density guide. And I think if you just type in either USDA or Forest Service stand density guide, it goes through the most common species and usually uses diameter as a variable for determining the number of trees per acre that is ideal. Now, keep in mind that these stand density guides were designed based under a current climate regime, if not even the climate regime back in the 20s and 40s when these guides were developed. So we have begun thinning to even lower densities in our pre-commercial thinning and commercial thinning. Another 10%, 15%, maybe at most 20% lower densities on the most droughty sites, just as another strategy. Another question.
Bert asked, should we be considering assisted migration for shrubs and forbs too?
Yeah, Kai.
Yeah, it's a great subject. And, one of the, I'll present my bias here because I, grew up in Spokane, so I've gotten to know a bit of both the east side and west side ecology. I really have thought a lot around that the species that we see both present on the west side, but then are also present into, maybe not present in the same capacity and numbers on the west side as we see them on the east side, but still some amount of presence, are then some of the species to really be considering as going to be increasingly drought tolerant and increasingly able to be resilient with some of the changes. So a few of those that I think are really great understory species to be considering: Saskatoon serviceberry, present in definitely San Juan County, certain parts of Western Washington, not so much, but certainly a highly drought tolerant understory species. Again, another great wildlife habitat plant. And then blue elderberry, of course, we have the red elderberry on the west side. Blue elderberry, which is both not to be confused with the black elderberry, which is the European variety, present both in the Cascades as well as the east side of the mountains. And another great one that is an excellent pollinator and found on both sides, but certainly in smaller numbers on the west side, is mock orange. So if you want to support those buzzers, not buzzards, but the buzzers, mock orange is a great one to add.
Lizzie's based in Idaho and asked if anyone has experience growing Gamble oak in the inland Northwest. Or if either of you know of that.
Haven't tried Gamble oak. No, I've planted a lot of different oak species. I come from Minnesota, where we have a wide range of oak species. So I've planted bur oak, some pin oaks, red oak, obviously the Oregon or Gary oak. So I think if you're not absolute native plant purist, I'm all about the arboretum and trying different species. As long as we have we're conscious of their potential to be invasive. But I think doing a little research into the biological characteristics of these different tree and shrub species, we can fairly quickly determine their potential to be invasive, but I don't see that with Gamble oak.
Yeah, no.
Or any oaks for that matter.
Yeah, exactly.
Kathy asked a great question. She's looked for west side Ponderosa pine seedlings for the past 2 years and hasn't been able to find them in the quantities she's interested in, like 50 to 100 seedlings. Do you have any ideas on where she can find them? And then generally maybe talking about sourcing seedlings for assisted migration.
I can't say specifically if they have. And the three nurseries that I usually go to first are these Webster Nursery, the State DNR Nursery, and then the Washington Plant Materials Center up in Bow. They provide a lot of conservation stock, planting stock. Yep. And then Fourth Corner Nursery also has a good diversity of plants. Kai, do you have anything to add to that?
Yeah, those are all three that I was going to mention. And with the plant center, it's great. They'll actually list species by Western Washington and Eastern Washington. So that there's interesting questions there of whether you want to get the same variety from Eastern Washington to play around with sort of a little test to see if it's actually more resilient for some of your landscape. But yeah, the plant center, they're more geared towards larger orders. And so I think they have a minimum of $300 per order. So oftentimes, and they also, it's like $1.25 a plant. So you can get a sense that there's quite a few plants that go into that sort of order. So potentially go in with your friends. They have a huge extensive list, and see if, you want to do a little cooperative buying of plants. They tend to also not sell until December, January, when plants go dormant. So kind of consider this upcoming winter as a good time. And then fourth quarter is, if you're on the west side and up towards Bellingham, you definitely can find a very extensive range. I don't think they have a lot of seed stock from Eastern Washington, but I do know the seed collector for fourth quarter, and they certainly do go to the east side. So I guess extensive seed collection from the east side, probably not, but they certainly have some seed stock from the east side. And again, much easier to buy smaller amounts through fourth quarter nursery.
Jennifer's question could be a whole fireside chat in itself. She spent many years working on eradicating English hawthorn on various sites in Washington and Oregon. What are your thoughts about invasive tree species that could tolerate climate change?
Well, I guess that's maybe where I do have a bit of native plant purist in me. We definitely, the species that we know are going to be invasive. So I think that let's are non-native species tolerant and adaptable to our region? That's one question. Do they show tendencies then to be very aggressive? English hawthorn, absolutely incredibly aggressive species. It's all over the hillside where my Oakville forest is. So I would be very concerned about that. Obviously, English holly, incredibly invasive plant, very drought resistant. It's just being bumped up now in our state invasive species criteria of concern because of it's so persistent. So I would be very mindful of these different plants' capacity to propagate and spread around, either from birds, rhizomes, et cetera, and be careful about that.
Great Green Yonder, did you have a follow-up question on that topic? I saw your hand raised for a second. Maybe it was an accident.
Oh, no, sorry. Yep, it was actually going back to the Ponderosa pines. Sorry, the conversation had moved on. I can hold it for later.
Okay. Carolyn asked, is anyone noticing an issue with big leaf maple? She's been noticing a lot of powdery mildew on trees right now in the San Juan County area. Yeah,
absolutely. Kai, do you want to speak to that?
It's the most extensive I've seen. It's totally pervasive, and a common phenomenon that what we normally see in smaller amounts this year is an extreme, but smaller amounts with these cool, wet springs that just provide a lot of habitat for powdery mildew. I don't think it's something to be overly concerned with. We're expecting that with another year and likely a different spring, that it shouldn't be super pervasive after this year, but certainly a stressor. It's slightly parasitic to the plant, and so it's we hope that won't be happening next spring, and that there'll be more resilient. Kirk, you have anything to add to that?
No, other than big leaf maple has been dying off all across the region and has been a focus of concern from the DNR and the University of Washington. They haven't been able to finger a specific cause for this region-wide die-off yet, other than just generally stating that it's the warming climate is what they're assuming is causing something to happen, but they haven't been able to identify either disease or an insect or other vector like that. It's very broad, so it's kind of an unknown, a little bit of a mystery of what's affecting big leaf maple. My hope is through the continued natural propagation of maple that new variants will develop that may be resistant to whatever's happening. That's just kind of common natural evolutionary theory. but that's a lot to hope for.
Yeah.
A lot of uncertainty there.
And we saw a lot of die off in San Juan County, or die back, maybe is both, especially after those 3 extensive drought years that we had. But yeah, I also talked to a DNR forester recently, Ashley Blinza, who was speaking to the issue of current research being done on the subject, and still, stay tuned, I guess, is maybe the best way to say it. We know some of the factors. Drought, they certainly don't like drought. But there's other factors that we don't know.
So I promised to also open this up more for some conversation, and given the remaining time we have left, I think I'd like to do that. And folks should have the ability to unmute themselves. Would anybody like to share any other observations, specific to their land or the forest that they're managing or that are near and dear to them? Observations that they're wondering, is this climate change? Is it something else? Or if you just have any other thoughts, would love to get kind of a free-for-all going. And if not, we'll keep taking questions.
I had just a quick question about the big leaves. I thought I heard earlier that they were sort of drought resistant, but now I'm hearing that they're not. So I'm just kind of confused. Are they or aren't they?
So they are a drought resistant species. I mean, they're very bimodal. They can take relatively wet sites and they can take relatively dry sites. So that's from a soil suitability, soil adaptability standpoint. But for some reason, with the increasing temperatures, atmospheric temperatures, that's having some kind of an effect on them. So when I say drought tolerant, I mean that the tree can tolerate droughtier soils than, again, say some of its other hardwood cousins, alder, cottonwood, certainly. So that's the distinction. I'm still encouraging people to continue to plant maple because it has such great soil building and wildlife biodiversity values, and kind of cross your fingers that it'll sort itself out. But again, planting it on on sites that are still fertile and not excessively droughty and not excessively wet. Goldilocks soils. Yeah.
And just to jump in there, part of why it's drought resistant is that it, as I said, the dieback phenomenon, it can, if it is starting to experience drought stress, it'll top kill down and then kind of find the equilibrium of what it can actually support with that amount of water. And so you'll see a lot of older growth, or not old growth, but older maples that have dead limbs up top but are super vibrant, and then when it has a good year, they'll start putting on a lot of extra growth and sort of compensate for that dieback the year prior.
Any other comments or questions or observations? Love to hear from the audience.
I'll jump in, Kirk.
Hey, Pete.
Hi. So the point you just made, Kai, about the top dying out of the maples, that's happening with the cedars for the same reason, right?
Certainly. Yeah, exactly. Good to see you, Pete.
Okay.
Yeah. It's a common phenomenon we're seeing all through San Juan County, and I think Kirk, I'm guessing you're seeing this through Western Washington.
Yep.
Yeah. So it doesn't mean that trees necessarily dying altogether, just trying to sustain a certain amount of growth is what I hear you say.
Yeah, cedar is very interesting in that way. Like the more drought sensitive species like hemlock and grand fir will just blink out. They'll die off entirely. What I see cedar doing is dying from the top down and then reaching some kind of equilibrium. And I think what it's trying to do is reduce its need to transpire soil moisture, to come into homeostasis with available soil moisture. So it'll die down to a certain point and then reach that homeostasis and kind of sit there like a stunted shrub with with this dead top to it, but not completely die off altogether. What good is that? Well, it's a great wildlife tree all of a sudden. But if that's happy, and this is, I guess a point that I didn't make earlier, as we think about moving species around our land and what to do with some of these, is again, you have to go back to your objectives. And mortality may fit very well into your objectives if your objectives are primarily wildlife habitat. Dead trees, snags, decay like that creates all sorts of opportunities for wildlife, both in nesting as well as forage. So some degree of mortality in your forest is going to be perfectly healthy, perfectly natural, in balance with your objectives.
I was going to make one other comment. Deborah and I planted 50 redwoods in an area of our forest that had laminated root rot. And we knew we shouldn't be throwing fir back in there for 50 years. So we thought we'd look for another species. And we were told at the time, and it might be you, Kirk, that told me this, I can't remember, but that wherever cedar would grow, we might have some success with redwood. Out of the 50 redwoods, we probably have 8 to 10 trees that are doing fine. And they're primarily ones that are in a shadier environment. They don't seem to like the sun. And so that's just an observation. I don't know anything about redwoods. I just hope they'll grow because we love the idea of them coming into our forest. But I just thought I'd share that.
Boy, yeah, I would have liked to have heard a higher survival rate than that if that was my recommendation.
Well, we have a higher survival rate. We have, out of 50 trees, how many survive? Probably 20 or 25 trees total, or maybe more, but a lot of them just were stunted.
Ah, okay.
And we also put them in groups. So we have maybe 4 to 5 trees all together. We have to figure out how to deal with that. If 1 or 2 are going to take off, do we try to transplant the other redwoods to the area? But not quite sure how to do that yet either. Anyway, just an observation.
Okay. Yeah. Thank you. Well, I'm happy to hang in there for just a couple more minutes. If anybody else has a question or a comment, it is 8:30 and we usually keep this pretty strictly to an hour. So if folks want to move on, I thank you for joining us. I'm willing to hang out for another 5 minutes or so, and then I need to go. But if anybody has any other questions or comments, happy to entertain them.
I don't want to dominate the conversation, but I have one more question. Given all of the species that you and Kai talked about, Kirk, that we could bring in to adapt for climate change, how much are we going to have to worry about deer browse and protecting every one of those trees? Or are some of those trees more tolerant and they could just take off on their own?
Yeah, most definitely. I'd say probably the most browse resistant tree is white pine. Both deer and elk just don't seem to really like its taste. So for the drought resistant trees, that's going to be, from a conifer standpoint, your best bet. I'm less familiar with the browse resistance of lodgepole or the shore pine. That's more common in Western Washington. I believe that's also relatively browse tolerant. Douglas fir can and can't be. It can tolerate a lot of drought, a lot of browse, and all of a sudden it gets a good growth here and shoots a leader up above browse height. So I typically don't cage Douglas fir when I plant it. If you get an east side variant of grand fir that's more drought tolerant, grand fir also is very unpalatable to browsers. I don't recommend planting the west side grand fir because it's not drought tolerant. So there's some conifer options anyway.
Yeah,
In Colorado, I'm not seeing, I'm seeing very little browse on lodgepole. So hopefully the ungulates out here don't have a different palate. But yeah, I don't see that they affect the lodgepole at all, really.
Okay, good to know.
Much of the damage done to our trees is with antlers. So the deer come in and they just want to rub the trees. We planted 4 sequoia in addition to those redwoods, and the deer got every one of those just by scraping the bark off.
Well, you also have too many damn deer in the San Juans. You know, I mean, you need more pit traps and timber wolves or something, or just people that are familiar with a rifle. Yeah, that's a whole other issue. Anyway, anybody else have any other comments, questions, or otherwise we'll wrap it up for the evening.
This is Chris Johnson. I have a tree farm looking at Anacortes, I guess you'd say. So similar weather to what you have in the San Juans. So it's a mature forest of Douglas fir for the most part. And I've had the most success with Sitka spruce and Alaskan yellow cedar. And I'm like, that's just the opposite of going to California, getting trees. You know? Kind of surprised me. But my question, and thank you for the comment on using rebar. I'm going to use that to go see what my soil densities are at different places, because I find some places the trees are just dying, other places they're going fine. And I'm mostly about habitat for birds and stuff. So, but my question is this: I have a desire. I love madrona trees. I sail through the San Juans every year. And I had 30, I'm down to 1. And it has a lot of trouble with blight, just black etching of the leaves. I've tried neem oil on it. I've tried various copper solutions as they suggest, but having a lot of trouble getting it to grow. Now, granted, I'm in the forest, so maybe that's the wrong place for that kind of tree to grow, but they're a beautiful tree. And I also have a sawmill here, so I love that wood, you know, so that's the other desire. But so that's my question. How can you fertilize them to help them grow stronger, or what can you do with madrona?
It's a great question. And Kirk may have some other insights. They, again, sunlight is one of their key needs. And so where you see them a lot, I mean, they'll sometimes make it within a more dense forest structure, but you see them a lot on the coastlines and the San Juans, part of why they're defining factors of the islands. So sunlight access could certainly be a piece of it. The blight, I've been seeing the blight more just over the last couple of years, and also Kirk, you might have some insights on why that's been increasing, or other remedies for it. But again, I think thinning and providing access to sunlight would be sort of my key recommendation.
Yeah, I've planted madrone out in a number of different conditions, and I found that as a young seedling, exactly, it does best where it has more light to it. I think once it's established, it can handle more shade. But my sense is that it typically regenerates, you know, in gaps and on disturbed sites. So that may be part of your issue. Is it needs more airflow as well as more sunlight. I know whatever the bacterial disease that's affecting it, trees are more susceptible when they're in a dense canopy versus having an open gap with plenty of sunlight and airflow. So I would try some experiments in planting it out, on south-facing edges, west-facing edges, or in gaps that get ample sunlight.
Good. I'll try. That sounds good. I'll try that. It is in too dense an area right now. Yeah. And
there may be some hope within a traditional disturbance regime with fire. They would just die off, but oftentimes they would resprout. And so there's indications that we've been seeing in the San Juans where sometimes they're like top killing and you think they're mostly dead, and then a lot of new growth is sprouting up afterwards. So there's definitely some hope that even if you have some pretty sickly looking madrones, they may recover.
Okay, folks, it's 8:37, or 8:38 now. So I think we're going to wrap it up. I thank you all for joining us. You will be receiving an announcement for our double header in September, and Kyle will be joining me for those also. Again, one of the topics at least will be managing for fire resilience and in the role of biochar or charcoal in forest ecosystems. We'll decide what the second topic is. And if you have any suggestions, feel free to email us and let us know. And we'll be happy to tackle the most popular idea. So with that, thank you, Kai, for joining us. Thanks, Alex, for running the show. And thank you, everybody, for joining us for tonight's Fireside Chat. And we'll see you hopefully next month.